So this is our second session. Let's continue talking about assembler and interpreter. We was saying that certain programs for large banks was written in basic language and even Fortran. From time to time, we still can see that they have job requirements for people who are able to write or even maintain software that was written with these old languages. You still can follow up with me, right?
Yes.
Okay, so interpreter take the software and translate it to the machine code line by line. But the problem with this interpreter that every time that you need to run the code, your assembly code, or whatever software that you created, you still need the interpreter. It still need to translate your code again and again. But so okay, and assembler in our case, actually, it take our code, the assembly code, and translate it to the machine code. But it do something smarter to us. It translate it to the machine code and it store it one shot in a format that doesn't need the assembler anymore. So the assembler do its job for one time. It translates the assembly code that we write, for example, the 3 lines that we created to add these 2 numbers, first and second. It will do a translation for it one shot to the machine code format. And then whenever we need to run our code to add 2 numbers, we don't need the assembler anymore. Okay, we just can run our command one shot. Okay, but the opposite side, the interpreter, we always need the interpreter to translate whatever lines of code that we have into the machine code. So you still remember, right? How the machine code looks like, and how the so the assembler. Yes, yeah. Exactly. So the assembler will take this kind of lines, okay, and it would translate it one shot to a machine code. But yeah, and as we said, the interpreter will do that line by line every time that we want to run our code. Okay, so you will say, why we use the interpreter? Actually, there is some certain benefits, but it's not used at the moment. But certain lines of code that is written even for all systems maybe still using the interpreter. That's why he's mentioning it here. So the interpreter is actually very easy to deal with, to debug and test our programs, and very easy to edit the program during development. So if I'm writing some lines of code and then I run it, and I discover that I make a mistake. During the running, I'm able to edit my code. Okay. I'll be able to show you that later. But with the compiler, no. The compiler actually also takes time to compile our code into a format of machine code that is able to run with the hardware. Okay. So it is somehow not so easy to deal with a compiler. It takes some time to do this compilation. And then if there is a mistake with our hardware, with our software, it will crash. And then we have to see how we rewrite our code again. So that's the difference between the interpreter and the compiler. The compiler, once you press compile, then it will take your whole code, translate it to the machine code, and then you cannot edit anything in the middle. You have to wait and see how your code will run and how it will operate. It will run correctly or it will crash. But the interpreter, no. If it crashes, you're able to edit your code while you're still running it, and then it will continue running, something like that. Okay? Okay. So we move to the next. Okay, now we talk about things that we might touch. Did you use any of those compilers before? IDLE or even PyCharm?
I've heard of IDLE, yes.
Okay, so IDLE actually is a software or the compiler that is downloaded when you try to get Python. So this is the basic one. Okay, PyCharm is slightly advanced and have more features. But yeah, idle can still do the trick here. Okay. Now, so this IDE actually it offers us an environment where we can write the code. So I can write the code in anything. Do you know a text editor? Have you seen a text editor before on the computer?
Is that just like, no, I'm not sure. No.
Oh, okay. So. Then okay. So let me see. Wait. Okay. So that is. Can you see my screen?
I can, yes.
Okay, so that is a kind of text editor. A notepad is a text editor. Okay. So if I am able to actually write the code here, and I'm able to pass it to Python compiler to be able to translate it to the machine code. But if I'm writing here and I write a mistake, I make a mistake while I'm writing the code, then there will be no highlight for the mistake. It's just a text editor that treat my code that I'm writing as if it's a normal text. It doesn't understand what language is that, and it doesn't offer to me. So normally, if we're working with idle, sometimes it will highlight to you that okay, this line is actually wrong, or maybe you are missing something here. So maybe if you forgot to put the name of the variable, it will highlight to you. Okay, this is more clear in more advanced IDE environment like PyCharm. Okay, maybe slightly idle is quite basic. Okay, and also sometimes you will find that when you're writing piece of line on the Python, for example, it will show a message to you here. Oh, did you mean that, or maybe you mean some other thing? So it will give you choices. Did you mean that or that? So that will happen not here on a normal text editor, but it will happen on when we're using a proper IDE like PyCharm. So let me stop here and then continue with this our slide. So that is what I mean, that when you have a good IDE, it will help you. It will make all the codes that you write in a proper colors that you can understand. Okay, and it will offer you. So when we write a piece of code, for example, to add two numbers and store the result in a third variable like we have done now. So if I'm facing a problem and then the result does not come as we expect, we said just now that the result of adding two numbers should be 110. Of course, this is a simple operation that it's very little chance that we can have a problem in our code. But there is certain operations that we will discover later that we can actually do mistakes, and we don't know where we did our mistake. So when we have a mistake or a problem with our code, we need something called debugger. So the debugger, if you have 10 variables, at any stage when you are running your software, the debugger is able to tell you what is inside the variables. And based on that, you are able to try to find where is your problem, or where is the mistake that you created in the code that makes the result, instead of 110, it become 109, for example. So if you are adding 10 variables, and you're not only doing an adding operation, you're doing multiplication, subtraction, and some divisions with 10 variables. So there is high chance that there is a mistake somewhere that happens with these 10 variables. It's not only two variables that we are adding. So, and maybe we are expecting all these operations to give me 110, but what I'm getting is 109. So there is some mistake somewhere that we need to find. if we are not able to see what is the content of our variable during the operation of our code inside the RAM, then it's very hard for us to get our code to run. And if you are having in big codes, like for example, the one I told you about in the first session, the line of code that we do, the program we do for the Android phones, that is trying to read some data for the patients, some medical data for the patients. Actually,
Yeah.
we are able to talk about 10,000 lines of code at least for this kind of software. So can you imagine how many variables inside? Actually, it's a lot. I don't think that there is less than 1,500 variables, at least. Okay, so there is very high chance that these 1,500 variables have some bugs inside or some mistakes that I created while I'm writing them. Okay, so by having a debugger in place, I'm able to look at any moment I'm running the program inside the mobile application. I'm able to know which variable is having which value at any time. Okay, this is only what you need to know at the moment, nothing more.
Yes.
So is it clear what the debugger can do?
Yes, I understand.
Okay, perfect. Okay, so actually when we are developing a program, there is certain processes that we need to go through. Of course, if we're talking about adding two numbers, it's very hard to apply this kind of cycles to it. But if we are talking about big programs, similar to the one I showed you previously, then we really need to look into these stages a lot. We need to analyze actually. When we are having a problem, we need to look at this problem and analyze it actually. Okay, what are we trying to do? What is the main purpose of the code that we are trying to write? We need to take the problem and define it properly to be able to come out with a proper program that can benefit the people. So if we're talking about benefiting poor people, for example, who are sick with certain kind of problems, if you don't focus on the people problem, then you will not be able to produce a software that they can use. You might spend 6 months writing a code that people will not benefit from it, that even they don't want to use it, or maybe they find it difficult to use, or maybe they find it it doesn't serve the specific purpose for their own problems that they are facing. So that's why we have to spend some time to analyze the real problem. We have to dig down and see what is the real problem that we are trying to solve. Okay, are we trying to solve a problem with a bank, or or are we trying to write something that operate a machine? You can write a piece of code that will operate inside the fridge. So what really we need to write, and what is something that is optional that we don't need to care about. So that's happening in the analysis phase. And then after the analysis phase, we come out with certain lines of definitions of the problems. And based on that, we are able to go to the design stage. And after we make a proper design, then we are able only to write a piece of code. In the design, we will talk about certain methods that we can translate the words of English or the definition of the problem that we write in the analysis stage, and we put it in something called flowchart or even pseudocode prior to writing a Python code, for example. Okay, and we will see that in details later. So that's just a small introduction. So now you know that program development life cycle is analysis, design. After coding, after you write the Python code, you need to test the Python code. You need to test your code, it's work properly or not. Does it crash? Does it produce the proper output? Is that clear to you?
Yes.
Okay. So let's move. Okay, so as I just said a few whiles ago, we need to, in the analysis, we need to do two things. We need to do abstraction and decomposition. We need to remove unnecessary details that is not required to solve our problem, okay? And we need to do also decomposition. So decomposition is actually breaking down a problem into smaller parts. When we are having a big problem, it is very, very hard for us to come up with a solution for it. So, but when we divide that big problem into smaller parts, and we take the smaller parts and also divide it into much more smaller parts, then only then we are able to tackle it. So actually, even that you can use it in the normal life. If you're having a big problem, you start with decomposing the problem into smaller ones, and you start to address the smaller ones. It's much easier for us to deal with than to deal with a big problem one shot. Okay, is that clear?
Yes, okay.
Okay, so let's say if you want to get dressed, okay, of course this is something simple, but we can divide that into smaller tasks. So first you select what to wear, and then maybe you need to remove any clothes that is being worn out, maybe from your closet, okay? And then the third thing is you put the selected items that you need to wear in order, so that you start wearing them based on the order that you put, okay? So that is that is kind of dividing or decomposing that you want to get dressed into smaller steps. Okay, so by dividing that, you're able to know, okay, how to deal with these smaller steps. So if the smaller steps also can be divided into much smaller things, also then it become more easier later. Okay, so this is the analysis stage.
Okay.
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 Okay. So let's talk about decomposition a bit. So typically in any system, we have inputs, we have outputs, okay? And we have something in the middle, a process that we do on the data. So let's say this is a system, okay? And this system do something inside here. It have an input and it have an output. And it have something that it do in the middle. So let's assume we need to make a converter from degrees Celsius to Fahrenheit. So this system do this kind of conversion for us. So you have an input and you have an output. So you have it, you put for here a degree, a temperature degree Celsius, and it does a conversion here with some calculation, and it output the result in Fahrenheit. Okay, so the process is inside here. This is the inputs, and this is the output. Okay, so it actually can be a code that we can write in Python that can take degrees to convert it to Fahrenheit, and can take also Fahrenheit and convert it to degrees. So this is the kind of software that we even can write. So by dividing what you expect at the inputs, and so you said first, you said, oh, I want to convert from Celsius to, I want to convert temperatures from Celsius to Fahrenheit and from Fahrenheit to Celsius. So you said, okay, what would be the inputs? So this is kind of decomposing the problem. So you expect here some integer values, and also you expect some values here, maybe with a decimal point. Okay, and you expect to do some calculation in the middle, some maybe multiplication and division here. So that is the process. Okay, and most probably, maybe many times we deal with our software. Sometimes we store the output of our software. So that is, if you need to store the output into a file, so that will be a third thing, a fourth thing that you need to do. So by having a problem, you decompose it into input, process, output, and then storage. Does this make sense to you?
Yes.
Okay. Is it difficult?
No, I understand.
Okay. Okay. So if we, so again, here we talk only about the analysis, and then we move to the next step, which is the design. So actually, when we come up with a definition for our problem, then we are able to represent that definition of problem as a design. We can use structure charts, we can use flow charts, we can use pseudocode. Okay, but I will not go to much details. I will take you to something separate as a refreshment now, but let me just show you how it looks like here. So this is what we call this structure diagram or structure chart. Okay, so I divide, if I have alarm app, I can divide that alarm app into small steps, or a small, how to say, a part like input, output, and processes in the middle that we need to do. Okay, so we call it smaller subsystems. So
Nice.
so that is a subsystem, and we take the bigger picture, we divide it into smaller subsystems, we decompose it, and this, we take that part subsystem and we divide it into smaller subsystems. Okay, but we will not talk about much details here. I just want to show you something, and then I will move to something refreshing. So that is how the flow charts looks like. Okay, have you seen flow charts before?
Yes, I have.
Okay, so you know how the flow chart looks like, or how it operates.
Yes.
Okay, and let me see. And here, this is how the pseudocode looks like. Have you seen pseudocode before?
Yes, I've seen a bit. I've
Okay.
seen a bit, yes.
So, but you know how to write a pseudocode?
No,
Okay.
no, I don't.
Okay. So yeah, so that is what we're going to learn actually during the course here. We will talk about how it looks like, how the variables look like. But this is actually, it's not pseudocode is not a programming language actually, and it doesn't have official compiler. So that is actually, this is something that you do before you write your real code in Python or high-level language. So it is more like English readable way to show that the design of your code, what you need to do, what kind of processes or addition or subtraction that you need to do to reach out a solution for the problem that you're trying to solve. So I think if you look at this line, then you're able to understand that, okay, he's subtracting the total price from a total price after he give a discount. Okay, he's calculating the discount to be able to reach the final price. So that is something that is readable. Also, you're able to understand that this variable or this thing is carrying maybe the amount of the discount or something like that.
Yes.
Okay, okay. So let us try to move to something that we use our minds in. Wait, give me a second, please. I will share with you my screen. No, not this one. I'm sorry. I need to share with you another screen. Okay, can you see my screen?
Yes.
Okay, did I share with you that screen before? Did you ever see it before?
No.
Okay, so okay, we talk about the IDE environment that we can use to develop high-level languages that can understand the lines of code that we write in. We talk about idle and PyChar, for example, just now. But recently, even in universities' syllabus, they start to include using Rebellet. Why? This is an online compiler that we can use. We can write
Yes,
Python,
I've
we
seen
can
it.
okay, we can write Java and many things. It's so easy that I'm able to share my code with you. You're able even to access, if I give you the link now, you're able to access that file that I'm operating, that you're able even to write when I'm coding. So there is more interaction here, and it's more, how to say, these more features that we are able to use when we are sharing in groups or even teaching. Okay, so let us. So most of our code that we will run it here. And if I give you exercises, I will also give it to you here, and you share it to me with links to your solution, also using that website. Okay.
Okay. Yes.
Okay. So a few whiles ago, we actually. So did you write Python before?
Yes, I have.
Okay. So do you know how to write? What level did you reach in dealing with Python?
Not exactly sure how to, as in, which things do I know? Or
Okay. Okay. So I will move slowly still, and then you highlight to me if I need to move faster or slower.
okay.
Okay. So I will start. So did you have any? Did you learn any programming language other than Python before?
I know C# as well.
Okay. So in C#, when you dealing with variables, did you hear about declaration before?
No.
Okay. So normally in most of language, we have to define our variable. So we tell the computer, please, okay, let's say.
Oh, yes. Okay. Yes.
So we tell the computer this kind of code, this kind of line, sorry, that please reserve a space in the memory for a variable of type string to hold a value. But actually, sometimes the declaration is like that only. Sometimes declaration is just like that. So please reserve a place in the memory that's and give it a name str. Okay, and that place will only carry strings. Okay, does this make sense? Okay, uh, and then at a later line or stage, then you will come here and do initialization of the variable. So we have two things that we have: declaration and initialization. Initialization, you put a value inside the variable. Okay, is that clear?
Yes.
And
Okay.
also you are able to do that in one line. You can declare and initialize in one line. Okay, but why I'm telling you that here? Because Python is a smart language, and it actually does not need declaration. But sometimes in the IG exam, he will ask you to write declaration. And so we will stop here. We will use the same link to enter again, and we will continue the same session here. Okay?
Okay. Yes.